Today we're going to talk about oxidation reduction reactions. If we have magnesium in a solid form, like we have a magnesium strip here, and it's in a copper ion solution. And if you let it sit over time, you'll see that you have a precipitate that is forming. And this happens due to the oxidation of magnesium. So you get that copper precipitate out of solution. So let's do a quick definition moment here. So oxidation is a reaction that involves the loss of electrons. A reduction involves the gaining of electrons. If I refer to something as an oxidizing agent, that's a species that gains electrons in a chemical reaction. It's what contains the element reduced. Reducing agent is a species that provides electrons in a chemical reaction. It's a species that contains the element oxidized. So here we have a little cartoon. We have two atoms. One says, "You've lost an electron. Are you sure you're all right?" And then this atom says, "I'm positive." That's a joke. If you lose an electron, of course, you're positive. Okay, so we went over all of these definitions, which is a lot, and it's hard to remember things. So here is another little way to remember. Here is Leo. He's a lion, and he says grr. Leo the lion says grr. Loss. This is loss of electrons is oxidation. Leo the lion says grr. Loss of electrons is oxidation. Gain of electrons is reduction. So that can help you remember which is oxidation and which is reduction. Leo the lion says grr. Loss of electrons is oxidation. Gain of electrons is reduction. There's also another way. If you can't remember Leo the lion, you can remember oil rigs. So, oil rigs, oxidation is loss, reduction. So you can see oxidation is loss, reduction is gain. Oxidation is loss, reduction is gain. So Leo the lion says grr or oil rig. Either way, those are two ways to remember. Oxidation is loss of electrons. Reduction is the gain of electrons. So if you're gaining electrons, why is it reduction? So let's think about what is happening to the charge. The charge is being reduced. So if we look and we have our reducing agent here, we have our oxidizing agents here, we have what is being oxidized. A here is being oxidized because A has these electrons and it loses those electrons, as you can see. B is gaining those electrons. So its charge goes from neutral, so that the charge was 0. You add 2 electrons. So now its charge is reduced. So that's why it's called reduction, because the charge is reduced. The charge itself is reduced. The oxidizing agent here is what is reduced. The reducing agent is what loses the electrons. Because it's the reducing agent, it's being oxidized. I know it's a little hard to wrap your head around. This is doing the reducing, and by losing those electrons, it's oxidized. Remember, oxidation is lost. So it was oxidized because it lost the electrons, but before it lost the electrons, it reduced B by giving it those electrons. So use the visual to see what reducing agent and oxidizing agent. They do the opposite. It's the oxidizing agent, so it gets reduced. It's a reducing agent, so it gets oxidized. Oxidation is loss of electrons, reduction is gain of electrons. So let's talk about oxidation numbers. Oxidation numbers are the apparent charge that an atom has. It's not really always the real charge, especially in a covalent compound, because we know covalent compounds don't have charges, but it's just the apparent charge. So if we were to look at how the compounds formed and say, well, this will have this charge and this would have this charge if they bonded, it's not a real charge in covalent terms. To determine the oxidation number of an atom in a compound, first, we know atoms in their elemental state always have an oxidation number of 0 because it's neutral. Aluminum doesn't have a charge as its pure element self. Oxygen, arsenic, sodium, all of those in its pure elemental form, they're neutral. The most electronegative element in the compound takes its charge. So you look where it is on the periodic table and you give it its charge based on its location. So fluorine is in group 17, it's a -1. Oxygen is in group 2. Oxygen is in group 16. It gains 2 electrons. Nitrogen is in group 15. It gains 3 electrons, etc. The most electronegative elements. Remember, in the periodic table, fluorine is the most electronegative. So this upper right-hand corner are your most electronegative elements. Francium down here is the least electronegative element. Now, metals take their charge. So they're going to take their charge. Sodium's in group 1, it's +1. Calcium's in group 2, it's +2. Zinc always makes the 2+ charge. Silver always makes a 1+ charge. The charges of all other atoms in the compound or ion have to be determined algebraically. The sum of the charges must add up to 0 in a compound, or the charge of the ion. So here, I want you to determine the oxidation number for each element in the following. So we'll do the first one together. Remember, the most electronegative atom is first, and it always takes its charge. So this oxygen's in group 16, so it would be 2 minus. In order to balance out that apparent charge, we look and we say, well, we have 2 hydrogens, and so hydrogen has to be a total of 2, but I have 2 of them, so each one will be a +1. I want you to try B, C, D, E, F, G, and H on your own, and then we'll come back and check them. Okay. Oh, these arrows are slightly off, I just realized. So with peroxide right here, hydrogen can't have more than +1. Because it can't have more than +1, oxygen therefore has to have a -1 apparent charge in this. Like I said, it's an apparent charge, so you have to realize it's not always going to be exactly from what the periodic table is. Sometimes nitrogen, for example, might have a +5, not a -3. But those are just general rules that I gave you. Okay, here we have carbon and oxygen. Oxygen's the more electronegative atom. Well, these are not right at all. So, yes, this one is a -2. And if oxygen is a -2, then this must be a +2 to balance it out. Here, for this one, we have -2 for our oxygen. And we have 2 oxygens. So 2 times -2 is -4. What does carbon have to be to balance that -4? Carbon has to be +4. So let's look at E. E, we have oxygen, which is 3. We have 3 oxygens here. Oxygen's your most electronegative. It's going to be -2. So now we have a -6, and this combination has to equal a total of 6. Well, we know that hydrogen can't be more than +1 because it only has 1 electron. That means that nitrogen has to be a +5 for this compound to be 0. Let's look at sodium sulfite. All right. Oxygen, again, is -2 because it's the most electronegative atom. We know sodium is going to be a +1 because it only has 1 valence electron to give up. So if this is -6 in total, and this is +2 in total, sulfur has to be +4 for the total to be 0. Now here we have potassium permanganate, and Oxygen is the most electronegative. It's -2. Potassium's in group 1. Group 1 metals always take their charge. So 4 times -2 is 8. This is +1. So manganese has to be +7 in order for this to be neutral. Here we have calcium nitrate. Remember, anything outside the parentheses gets distributed in. So here we have -2 because, of course, oxygen is the most electronegative atom and it takes its charge. Calcium is +2 because it's the metal, it always takes its charge. So we have 2 plus here. 2 times 6, or 2 times 3 is 6, because remember it gets distributed in. So that's a -12 total. So nitrogen then, and we have 2 of them because it also gets distributed in, has to be a total of 10. So that would be 10 divided by 2 to make that +5. So calcium is a +2, nitrogen is a +5, oxygen is a -2. Okay, I want you to try I, J, K, and H, and then come back and check your answers. Sodium here is +1, carbon is +4, oxygen is -2. We do oxygen first, it's -2, which means nitrogen has to be +4. Here, oxygen's the most electronegative, it has to be -2. Sulfur is +1. Or sorry, hydrogen has to be a +1, so sulfur has to be a +6. Oxygen here in L is the most electronegative, so it has to be -2. Sulfur or hydrogen can only make one charge, so it has to be +1, which means sulfur has to be +6. Here we have an M. Sulfur is the most electronegative. It's -2. And aluminum is a metal. It always takes its charge, so it has +3. Manganese and chlorine. Chlorine's the most electronegative, so it's -1. Manganese is +2 because we have 2 chlorines, so the charge has to balance out. Here we have carbon, hydrogen, and oxygen. Oxygen's most electronegative. It takes the -2. Hydrogen can only make +1, so it's going to be +1. Given that, and we have -12 plus 12, carbon has to be 0 because the -2 is times 6 is 12. Hydrogen is always +1, so it's 12. Carbon in this compound we give a 0 to. Here we have manganese oxide. We have here a -2 because oxygen's -2. And then manganese, this is a little tricky. It's 8/3 to balance out the -8 charge. Like I said, it's not perfect, but I wanted to give you some examples that weren't completely straightforward so that you could understand. Now, a reaction between magnesium and copper 2 plus ion will produce copper and magnesium 2 plus in an aqueous solution. This is a picture we saw at the beginning. So, because magnesium lost 2 electrons, as it went from magnesium to magnesium 2 plus, it was oxidized. It also acted as a reducing agent. It reduced the copper. The copper 2 plus became copper with a 0. It was completely neutral. So because we had a negative value added to it, it was reduced. If it's reduced, it is also the oxidizing agent. So here, if we look, we're going to assign charges. This is why we practice assigning charges, so we can determine what was oxidized and what was reduced. So here you have sodium and chlorine. We've determined the oxidation numbers for each. Sodium became +1. Chlorine became -1. So if we look, say, well, oxidation is lost. Loss of electron. So either oil rig or Leo the lion goes grr. Oxidation is loss. So the substance oxidized was sodium because we went from a 0 to a +1. We lost that electron. The substance reduced was chlorine because we went from a 0 to a -1. It gained the electron. Its charge was reduced. The oxidizing agent was Cl2, and the reducing agent was sodium. It's a reducing agent because it was oxidized. So here we have another one. I want you to try this one. We have iron, oxygen, and our iron 3 oxide. I want you to try this on your own and then come back and check. So first we assign the charges. After we assign the charges, we determine what has been oxidized and what has been lost. Oxidation is loss of electrons. Which element lost electrons? Iron did. It went from 0 to +3. Which substance gained electrons to be reduced? That would be your oxygen. So your oxidizing agent then is what was being reduced, which was oxygen. And your reducing agent is what was oxidized, which is iron. So I want you to try this one again. And then come back and check your answers. So we have Fe2O3 plus carbon monoxide produces Fe2 oxide, iron 2 oxide, and carbon dioxide. So what was oxidized? In order to determine that, we need to find the apparent charges for each element in the reaction. Okay, now we've done that. So what was oxidized? We have iron 3 plus goes to iron 2 plus. Did that gain or lose an electron? We have oxygen here, -2. It's -2 here, -2 here, and -2 here. Was there any change in that charge? Carbon, we have +2 and +4. Did we gain electrons or did we lose electrons? So the substance oxidized, in this case, was carbon monoxide right here because it gained an electron. So in this case, we look at the whole compounds. If it's not apparent for just looking at one molecule or one atom, we look at the whole compound. So the substance oxidized, we notice that the carbon itself is part of the carbon monoxide. The carbon lost the electrons. So therefore, carbon monoxide is the substance oxidized. The substance reduced then would be our Fe2O3 because we see that it lost from this side to this side, it lost some oxygens. The iron itself, you can see, changed in other ways. The oxidizing agent is Fe2O3. The reducing agent is carbon monoxide. So you had to look at it as a whole thing. We know that iron was reduced, but iron wasn't by itself. So you have to say, well, this whole compound, iron 3 oxide, was reduced. Okay, let's look at this one. I know they're getting a little bit more complex, and that's okay. Try it and then come back. See how you did. Assign charges. Now that we've assigned charges, go back and forth and look what happened. We have copper 2 plus, copper 2 plus. Nitrogen plus 5, nitrogen plus 5. Oxygen -2, oxygen -2. Oxygen -2, oxygen -2. So, was anything reduced? Was anything oxidized? No. So, not all reactions are oxidation reduction reactions. So, this one you can look through and see not all of them are always going to be oxidation reduction reactions. Okay. Try this one and come back to check your answer. Oxygen has a -2, manganese has a +7. Make sure you have assigned your charges. Now go and look what happened. What do you notice about manganese? What do you notice about oxygen? What do you notice about hydrogen? What do you notice about arsenic? Now, let's look what was oxidized. That would be your HSO3. That was oxidized because your arsenic lost an electron, and it's part of this compound. So what was reduced, that would be your manganese. It gained 5 electrons. So in your permanganate ion, that's your substance reduced. Your oxidation agent then is your permanganate ion. And your reducing agent would be this ion. Okay, practice. I want you to try these and then come back and review them. So, what's the oxidation number of sulfur in H2SO4? We know that oxygen is the most electronegative, so it's -2. Hydrogen can only be a +1. So we have 2 plus something plus a -8. So for this overall to be neutral, sulfur has to be a +6. So that's D. 2, which of the following is not a redox reaction? So you have to assign charges to each. So our zinc is 0. Oxygen is -2. Copper can either be +1 or +2. So this is a little bit trickier. We would say, well, oxygen's -2, that's -8. Sulfur then would have to be +6, and copper would be +2. Come over here, zinc is always +2, sulfur is a +6, this is a -2, and copper is 0. So what was this? Well, so this is an oxidation reduction reaction because zinc has been reduced and copper has been or zinc has been oxidized and copper has been reduced. Okay, so let's look at B. So we know it's not A. That's an oxidation reduction reaction. Here with B, we have hydrogen at a 0 and oxygen at a 0. This is a -2 and this is a +1. So it's not B because B is an oxidation reduction reaction. So let's look at C. So C, we have AgNO3. This is -2. Silver's always 1. So nitrogen has to be a +5. Plus NaCl. This is -1. This is +1. Produces AgCl. This is a -1. This is a +1. Plus NaNO3. That's -2. This is a +1. This is a +5. So +1, +1, +5, +5, -2, -2, +1, +1, negative. There's no change. So here, C, since there's no change in any of these oxidation numbers, the answer is C. 3, in the reaction, Fe plus Cu2 plus produces Fe2 plus CuFe. Which species is the oxidizing agent? So remember, oil rig, oxidation is loss. Well, we go from a 0 to a 2 plus. So Fe was oxidized. If it's oxidized, It's the reducing agent. So we know it's not A. 2 plus, copper 2 plus. Reduction is gain. So let's look. 2 plus, and here we have, let's give you another example because I just realized this is not a compound. But this one doesn't work. But it would have to be in like CuO, for example. So I'm not sure what it did there. So let's change this to be CuO, like copper oxide instead of copper Fe. So, and then this would have the oxygen there. I'm going to give you a new problem. Fe plus CuO produces FeO plus Cu. That's what it should have. So if we do this, this has 2 plus. This is, sorry, since that's by itself, that's 0. This is 2 plus. This is 2 minus. This one is 2 plus. This one is 2 minus. And the copper is 0. So your copper 2 plus that was with your oxygen is what is the oxidizing agent because copper was reduced. And if it is what is reduced, it's your oxidizing agent. All right, we're done for the day. If you have questions, let me know. I'm happy to help.